How are you, my friends? This is review questions number 2 on inverse functions, exponential and logarithmic functions. Question 1a, find the inverse of the function f of x is equal 4x plus 3 divided by x minus 2. Now, to find the inverse for this function, we have to use the 4 steps. Put f of x is equal to y, and then interchange x and y. And we know this function is 1-to-1 because it is a rational function. So x equals 4y plus 3 divided by y minus 2. Cross multiply here because we need to solve for y. So xy minus 2x is equal 4y plus 3. Move all the terms that have y on one side, everything else on the other side. Take y as a common factor, so y times x minus 4 inside the bracket is equal to x plus 3. Let's divide by x minus 4, so we will get y equals 2x plus 3 divided by x minus 4, which will be exactly the inverse function. 1b, find the inverse of this function r of x 1 minus ln of x plus 3. This is a logarithmic function, so we expect the inverse to be exponential. Also, we use the 4 steps. R of x now 1 minus ln of x plus 3. Let's replace this function here by y, and then interchange x and y, so x will be 1 minus ln of y plus 3. Put this in one side, and then it will be 1 minus x. So ln of y plus 3 is equal 1 minus x. Let's use the LE rule to change this logarithmic equation here into exponential. So this is logarithmic exponential rule. So it will be y plus 3 is equal e to the power 1 minus x. I need y, so y will be e to the power 1 minus x. I can leave it, or I can write it minus x plus 1. Minus 3 on the other side also. So this will be the inverse function of r. So r inverse of x will be e to the power minus x plus 1 minus 3 on the line. Question number 2 says, where the graph of the inverse of this function f of x equals minus square root of x plus 4 plus 2 is below the x-axis. Now this function is half parabola, and it's 1-to-1 also. So we can find the inverse and then check where the graph of the inverse is below the x-axis. Now here's the function. We graph it first. This is the black graph. So it's a square root of x, half parabola. And then there is a reflection here with this minus on the line, reflection on the x-axis, and then shifted 4 units to the left, and then 2 units up. So the graph here becomes from minus 4 until infinity. This is the domain of the f. So the black one is the graph of the function, the given function. The domain will be minus 4 to infinity, and the range also we can see minus infinity until 2. So this point here is minus 4, 2. It's also passing through the origin 0, 0. Now let's find the inverse using the 4 steps in lecture number 1 from the pre-calculus course. So we put f of x as y, then we interchange x and y, square both sides, then we get y equals x minus 2 squared minus 4. Now this is the inverse. F inverse of x will be x minus 2 squared minus 4. Now be careful, you cannot leave the answer like this. Why? Because this function here, which is the inverse, is a complete parabola. Now just compare this with the last line here. The same function, x minus 2 squared minus 4, x less than or equal to 2. You have to mention the condition to make this function 1-to-1, which is also half parabola. From where we get this condition, x less than or equal to 2, that will be the domain of the inverse, which we can get from the range of the f. Again, I will mention again, on the black graph, the range will be minus infinity on the y until 2. So minus infinity to 2 is the range of the f, which is the domain of the inverse. So that will be directly the condition. So minus infinity to 2 is exactly x less than or equal to 2. So this point minus 4, 2 on the graph of the function f, if you interchange x and y, this is 2 minus 4 on the inverse. The question says where the graph of the inverse, which is the red one, is below the x-axis. So from 0 open until 2 closed. This is where the graph of the inverse is below the x-axis. Now, question number 3, if the function f of x is equal 4 over 5 to the power 2 minus x plus cube root of minus 1000 is written as f of x t times a to the power x plus n. Find the value of t times a times n. Here we have to play with the powers. So we can use the rules of exponent backward. We know a to the power m times a to the power n is equal a to the power m plus n from algebra. We can go back and make it two quantities multiplied by each other with the same base. So I can make here 4 over 5 to the power 2 times 4 over 5 to the power minus x. Now 4 over 5 squared will be 16 over 25. 4 over 5 with the power minus x, I can take the minus and then flip this fraction 5 over 4 to the power x, and then there is a minus 10 from the cube root of minus 1000. So now t is this coefficient here, 16 over 25, a is the base 5 over 4, n is minus 10, because this is plus n, and here we write plus in the bracket minus 10. Now let's multiply 16 over 25 times 5 over 4 times minus 10. When you simplify, you will get minus 8. Question number 4 is nice question. Let's find the range of this function. It looks so huge. So what do? Simplify the function first. How do you simplify? Multiply the first two brackets. There is a minus here. Multiply the other two brackets here, and then subtract, and then divide by this. Leave now this one squared. You can expand it, but you can also leave it for a minute. And then the function will be simplified function. So let's multiply by the FOIL method. E to the power 2x times e to the x will be e to the power 3x. We add the power. E to the power 2x times 2. E to the power 2x will be 2, the coefficient. E to the power 4x. Multiply this and this will get e to the power 4x. The last one here. 2 times e to the power 5x minus the same idea here. You multiply inside the bracket. Remember, you multiply inside the bracket, then we have a minus outside, so we can subtract. Now, let's see. When you subtract, you get minus e to the power 3x minus 2 e to the power 4x minus e to the power 5x. Now, let's take minus e to the power x as a common factor. So we have e to the power 2x inside plus 2 times e to the power 3x plus e to the power 4x. Now, this one squared. So we can write e to the power x. A squared plus 2ab plus b squared becomes a plus b squared. You can use the expression now in this bracket as e to the power x plus e to the power 2x squared. Because when you apply this formula here, a plus b squared, it will be this one squared plus 2 times this becomes 3x, and this one squared becomes e to the power 4x. Now all this expression, same as this expression, you can cancel. And now what's left now, f of x will be e to the power minus x. This one dashed one is e to the power x, the increasing exponential. When you have a minus on the line, it's a reflection on the x-axis. Now, what is the range? From minus infinity until 0 open. That's the simplified function. Question number 5, find the value of the expression log base fourth root of 3 of this quantity, log base 2 of this quantity, log base square root of 3 of 81. So what do? We start with the inside. Log base square root of 3 of 81, that's a simple number. And the whole idea here, we use the LE rule, y equals log base a of x, if and only if x equals a to the power y. So I can take the inside the bracket here, log base square root of 3 of 81 as x. Now 81 will be square root of 3 to the power x. 81 will be 3 to the power 4, and square root of 3 will be 3 to the power half. The power half times the x will be x over 2. Now the same base, so we have 4 equals x over 2. X will be 8. Now I have 8 here. Then log base 2 of 8, that's easy. 2 to the power 3, or you can use also, let's call this value y. Same idea, change it to exponential, y will be 3. Now we have w. W is the whole quantity, the whole expression. W is equal log base fourth root of 3 of 3. So 3 equals fourth root of 3 to the power w. Make both sides the base 3. This will be 1 over 4. 1 over 4 times the w and the power. So 1 equals w over 4. W will be 4. So the whole expression will be 4. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.